2 weeks ago, we talked about the electric grid system, looking at how we get electricity when it is produced in a matter of seconds. But there's a problem. And what's that problem? Well, with the increasing demand of electricity in this 21st century, from the introduction of new inventions such as electric vehicles, and with many more to come in the near future, our current electric grid system, which was designed long ago when electricity demand was not high, might not be able to cope. But there seems to be a solution. I am Godswill and this is No Engineering. On this episode, we are looking at the smart grid system. But before, do me a favor by subscribing and sharing. Thank you very much. Welcome back. So what's a smart grid? The smart grid is an electricity network enabling two-way flow of electricity and data with digital communication technology, which will enable systems to detect, react, and pro-react to changes in the usage and multiple issues associated with the electricity system. This is achieved by integrating information, telecommunication, and power technology with the existing electricity system. So let me explain this so that we all understand this very well. We know that electricity is produced at the various power plants, and the electric grid carries that electricity to our various homes and businesses. But there's one thing, the current electric grid is running on capacity, and the problem that may come with it is there might be power outage if there's a break in the power lines, or the power plants cannot produce enough electricity. And most of you will agree with me that that will actually minimize productivity. Another thing is, the current grid does not give us detailed information of our use of electricity, so it makes it difficult to manage electricity. With this, if there's an increase in demand, more power plants have to be built, but with a smart grid, we can still meet demand without having to build more power plants. The smart grid, in a simple language, we will say installing sensors and softwares on the current electric grid. This will give us data about our energy consumption and other issues to allow us to respond to changes quickly. For example, let's say there's a storm and it causes a break in the power line, leading to some communities losing power. With the current grid, power authorities will have to off that part and reroute or fix the fault before restoring power, and that might take a much longer time. But with a smart grid, sensors will quickly detect the fault and the softwares will reroute immediately, then sending information to the power authorities. That seems to be more effective. You agree with me, right? Another advantage of the smart grid over the current grid is the ability for us to minimize our cost of electricity. You see, the prices of electricity changes throughout the day. That is, electricity is usually expensive during peak hours, and that's the day, and less expensive at night, where most people don't use electricity. With a smart meter, we can set our appliances to run when the electricity is much cheaper. For example, we can set our washing machine to run maybe at 3 a.m. when power is relatively cheaper. By this way, we save cost and even prevent blackouts during peak hours, since the pressure on the grid will be minimized during that time. Environmental pollution is one problem that humanity has been facing for so many years now. The smart grid enables integration of different power sources. That way, more green sources will be introduced to the current grid, making the grid more stable and efficient. The smart grid clearly is a good development. Continents like the Americas, Europe, and Asia are currently working on its development. I don't know about Africa though, but it seems to be a very good option for us. And you, what do you think? Let me know in the comment section down below. But anyway, thank you very much for watching the video. Subscribe and share. Bye.